Okay, so this is going to be a video for the worksheet that we're going to work on with completing the square. What you have to understand about the idea of completing the square, sometimes we end up with these quadratic problems that might have like an x squared. So think of a rectangle here. Here we go. Where we have like an x by an x that creates our x squared, and then x by, say, 16. And if I have x by 16, that would be 16x. And this is a rectangle, and it's actually pretty difficult to solve when there's other numbers involved. If this was all I had, it'd be pretty easy to work with. But the idea is I want to actually turn this rectangle into a square. Squares are easier to work with than rectangles, and so we want to shift this around, and we can add a number to it. We don't want to add any x's, but we could add a number. And so the fundamental idea here is that we're actually going to take this 16x and we're going to split it in half. And we're going to move this half right here off, twist it, and put it down here. So instead of being 16 anymore, now this is 8x and this is 8x. Okay, so these two rectangles over here are 8x and 8x. So the fundamental question we want to answer is, if that's 8x and 8x, then what's this area over here? This is our first question. What's that number that's missing? Well, if it's 8 along this edge and 8 along this edge to create the 8x in each corner, then 8 times 8 would be 64. Now, is there a quick way to find that number? Well, there actually is a pretty quick way. Now, this does depend on this being a 1x squared. But if we have a 1x squared, which is what you're going to get in Algebra 2, this first go around with completing the square, it's going to be a nice 1x squared. So we want to know, is there a quick way? Well, with this 1x squared here, okay, there's a way to find this 64 using the middle number. Remember, it was x squared plus 16x. If we focus on this guy right here, to find the perfect number to add or to put in the corner, what we're going to do is we take that 16, we're always going to divide it by 2. That'll produce the number 8. After we've got the 8, we're now going to square that number. We call it completing the square. And so that 8 squared becomes the 64 that we were looking for. So if we look at this first half of the worksheet, it's asking us to find the perfect value to complete our square. Whether it's addition or subtraction, it doesn't matter. We're going to find the perfect number by dividing by 2. Always this middle guy. 18 divided by 2 is 9. 9 squared equals 81. So the perfect number here is 81. Down here with 42, half of 42 is 21. 21 squared, well, I'm going to need a calculator for that. I'm sure it's 400 something. But let's just give it a quick go. 21 squared is 441. So we got 441. That would be our number to put in the problem. Now, one of the reasons that we do this complete the square is it actually makes it really easy to factor. So once we've gotten these written in this perfect square format, now when I go to try to factor this, I've got x and x. And how do I split an 81 so that it adds up to 18? Oh, I use the square root, which would be 9 and 9. This sign's positive, so my signs have to match. To get a positive 18, I need a plus 9 and plus 9, which finally allows me to write it as a perfect square. This is there are two answers to this question. The number 81 is the perfect number to add, and then writing it as x plus 9 squared. Well, if I did the same thing for number 3, x and x, now you might get to where you can jump straight to the squared parentheses. And if you can, that's awesome. We just want to make sure we're careful and thoughtful about it. Well, how am I going to split the 441 so it adds up to 42? The answer is always in the squared number. because 21 times 21 is the 441, I can put my 21 on each of these and feel pretty comfortable. Now notice, we still have a plus here. That means my signs have to either be plus plus or minus minus. They have to match. To get a negative 42, I'm going to need negative numbers, like negative 21 and negative 21. So my final answer is x minus 21 squared. Now, that's an example of how to do these problems. But what's the point? How does that actually help me solve these problems? Well, let's jump down here to a question like 23. Okay? Some of these are going to be easier than others, but we're going to work our way through them. I'm going to look at 23 and 24 with you. On question number 23, we notice we have this 14n. And if we think about what its special number is, we would divide it by 2. That would equal 7. And 7 squared is 49. I don't like this 62 here. I wish it was a 49. So what I'm going to do, and there is more than one way to do this, but what I'm going to do is I'm going to get rid of that 62 and I'm going to put in a 49. Now to do that, I'm going to minus 62 from both sides. And at the same time, I want to add my 49. Now whatever I add to one side, I have to add to the other. But this gets rid of what I don't want and lets me add in the number I do want. 14n plus 49 now equals whatever all that stuff is. So let's find out. We have 49 plus 3 minus 62 is negative 10. All right, so we're at a negative 10. Negative 10. All right, so now I can factor this n squared problem as n. I'm going to use 7 for my 49 because 49 is 7 times 7. That gives me my 14. And notice all my signs are pluses, so I'm going to use a plus here. This now equals negative 10. If I'm trying to solve this problem for n, it's worth noting that that's the only n in the problem. And so if I can just peel the layers back, get rid of the square, get rid of the 7, my answer for n will be staring me in the face. I'm going to work from the outside in, trying to isolate my n. To remove the square, I'm going to take a square root. And when I take a square root of a number, I'm going to insert the plus or minus in front. This is now n plus 7 equals plus or minus the square root of negative 10. Now, I don't know about you, but I know I don't know the square root of 10. And the negative, that reminds me that this is actually an imaginary answer rather than a real number solution. So I'm going to have a plus or minus I root 10. So far that's where I've gotten to. I'm not done yet. I still have my n plus 7. But in simplifying my square root, because it was negative, I'm going to put an I because it's imaginary. And don't forget you have your plus or minus in front of it. Now to get n alone, I just need to remove the 7. We always like to put any addition subtraction stuff in front of the plus minus. So I'm going to write that over here. And finally, the answers to 23 are negative 7 plus or minus I root 10. Sometimes they're real answers, sometimes they're imaginary. It just depends on the problem and the numbers that we're working with. Okay, now that one was pretty easy. Some of these, you'll notice, look a little bit tougher. And the reason that they look a little bit tougher as we get further into the assignment, I think the first 7 of them are pretty good here. And then the last 7 are a little bit nasty. And what's special about them, and your math teacher might decide to change this number, but this 9, it doesn't divide nicely. So I'm going to go ahead, I'm going to minus the 68, get it out of here on number 26. Let's go. M squared minus 9m equals negative 60. Now I need to add the special number. it's half of 9, so it'd be 9 over 2, it doesn't divide nicely, squared is 81, 9 squared is 81, over 2 squared, that's 4. So I'm going to add 81 over 4 to both sides. Whoops. These are definitely going to be a little bit messier because of that fraction. But the good news is, totally workable. We're going to keep working on it till we get it finished, all right? Probably need to use my calculator a little bit along the way. Remember, this divided by 2 is not really there. Okay. M squared, I'm going to do the factoring. Remember, it's always this number that's half of the middle guy or the square root of the last guy. That's where the 7 comes from. So the square root of 81 over 4 would be 9 over 2. That's also half of this middle guy. I'm positive, so my signs have to match. To get a negative 9, I need negative numbers. And that will equal. Now over here, I'm going to use my calculator to make this real pretty. I'm going to take my negative 60, and I'm going to add my 81, divided by 4. I don't like that, so I'm going to turn that into a fraction using my math frac key. I know you're not going to like it, but get over it. Negative 159 over 2. Seems like I got a lot of imaginary number problems on here. Yep. Oh, it's over 4. Over 4. My bad. To get my m alone, I need to take a square root of both sides, which introduces a plus or minus. I'm going to stay with me here. M minus 9 over 2 equals plus or minus. Now 159 doesn't divide nicely by a lot of numbers. Let's try just checking our calculator. Y equals 159 divided by x. If I go to my table and look for numbers, I'm looking for whole numbers to come out. Looks like 3 goes into it and 53, but those are not numbers that have square roots, and I think that that's probably about all that'll go into it. So that means I'm going to write I root 159 over, but I do know the square root of 4 is 2. To finish the problem, I need to add the 9 halves to both sides to get m equals 9 halves plus or minus I root 159 all over 2. Again, another imaginary answer, and because it was this odd number in the middle, it sure made the simplification a little bit messier because of the fraction that floats around. So again, your math teacher might decide to change a bunch of those to be even numbers just to make the problems a little bit easier to work with. All right, good luck. We'll see you guys in class.